Hi friends, welcome to our lesson. I'm Mrs. Gradney, and today we'll be multiplying multiples of 10, 100, and 1000 by single-digit numbers. Here's what you'll need for our lesson. Let's get started. Let's read this expression together. 2 ones times 4. Now pause the video, and on your place value chart, draw discs to show 2 ones times 4, or 4 groups of 2 ones, and circle each group of 2 ones. So 2 ones times 4 is what? It's 8 ones. Okay, let's erase. And now on your place value chart, I'd like you to pause the video and show 2 tens times 4. And circle each group of 2 tens. So 2 tens times 4 is what? 8 tens. Okay, let's erase. And now on your place value chart, I'd like you to pause the video and show 2 hundreds times 4. And circle each group of 2 hundreds. So 2 hundreds times 4 equals what? 8 hundreds. Now let's think a little bit about what we just did. What do you notice about multiplying 2 hundreds times 4 as compared to multiplying 2 tens times 4 or 2 ones times 4? Pause the video to talk out loud about what you notice. You may have noticed that there are the same number of place value discs each time we multiplied. There were 4 groups of 2 units. But the value of the place value discs were different, and so the products were different. So what do you think would happen then if we multiplied 2 thousands times 4? Pause the video to explain your prediction. I have a friend over here who said he thinks it would look the same again. We would again have 4 groups of 2 units. But this time, the value of the place value discs would be thousands, and so the product would be 8 thousands. Is that what you predicted? Great thinking. Let's try another problem. 8 times 2, or in unit form we could say 8 times 2 ones. Pause the video and use discs to represent 8 times 2 ones on your place value chart, and circle each group of 2 ones. So 8 times 2 ones equals what? And remember to say the answer in unit form. 8 times 2 ones equals 16 ones, which in standard form is 16. Now, here are 3 more expressions. And in a moment, I'll ask you to pause the video to do some work. And here's what I want you to do. I want you to use discs to represent each of these expressions on your place value chart, and then solve each expression in unit form and write the product in standard form, just like we did here. And then when you get back, we'll compare. Welcome back. Be sure to compare your work to mine and make any changes if you need to. Now, I want you to think, what patterns did you notice as you solved these multiplication problems in unit form? Pause the video to talk about the patterns that you noticed. You may have noticed that all of the problems had 8 as a factor. Or maybe you noticed when you looked at the discs that each time we drew 8 groups of 2 discs. Each time we multiplied, we had 8 times 2 of some unit. And whatever unit we were multiplying by, that was the unit we ended up with in the product. So when we multiplied 8 times 2 ones, In the product, we got 16 ones. When we multiplied 8 times 2 tens, in the product, again, we got that unit of tens. When we multiplied 8 times 2 hundreds, we got 16 hundreds. And when we multiplied 8 times 2 thousands, we got 16 thousands. You may have also noticed a pattern in the zeros. When we multiplied by tens, there was 1 0 in the product, just like 1 0 in the tens. When we multiplied by hundreds, there were 2 zeros in the product, just like there were 2 zeros in the hundreds. And when we multiplied by thousands, there were 3 zeros in the product, just like there were 3 zeros in the thousands. Great noticing. Now, let's look a little bit more closely at 8 times 2 hundreds. What do you predict would happen if we changed the unit from 8 times 2 hundreds to 8 hundreds times 2? Pause the video to think about this, make a prediction, and then test your prediction. When you get back, we'll discuss it. Welcome back. Did you predict that the products would be the same? Why are the products the same? In the last lesson, we learned that 8 times 200 can be decomposed into 8 times 2 times 100 because 200 can be decomposed into 2 times 100, and 800 times 2 can be rewritten or renamed as 8 times 100 times 2 because 800 can also be decomposed into 8 times 100. And now we can see that when the factors are decomposed like this, they have the same factors. 8, 100, 2. 8, 100, 2. And because we can multiply in any order, this shows that both statements are equivalent. Let's try some more problems. Read these expressions with me. 4 times 3, 4 times 30, 4 times 300, 4 times 3,000. Now pause the video and solve each of these expressions in unit form and write the products in standard form. If it's helpful, you can feel free to draw discs on the place value chart if it will help you. Then come back and we'll compare. Welcome back. Check your work with mine. Now, what patterns did you notice as you solved these multiplication problems in unit form? Pause the video to talk about what patterns you noticed. You may have noticed that with each multiplication, we had 4 times 3 of some unit. And whatever unit it was that we were multiplying by is the unit that we see in the product. So 4 times 3 ones is 12 ones. 4 times 3 tens is 12 tens. 4 times 3 hundreds is 12 hundreds. And 4 times 3 thousands is 12 thousands. That's the same as what we noticed last time. You may have also noticed that pattern of zeros that we noticed last time as well. When we multiplied by tens, there was 1 0 in the product, just like there was 1 0 in the tens. When we multiplied by hundreds, there were 2 zeros in the product, just like there were 2 zeros in the hundreds. And when we multiplied by thousands, there were 3 zeros in the product, just like there were 3 zeros in the thousands. Great noticing. I wonder if that pattern always works. Let's try some more problems. Read these expressions with me. 5 times 2, 5 times 20, 5 times 200, 5 times 2,000. Now pause the video and solve these expressions in unit form and write the products in standard form. If it's helpful, you can draw the place value discs on a place value chart. Then come back and we'll compare. Welcome back. Check your work with mine. Now let's talk about patterns again. Earlier in the lesson, we noticed a pattern of zeros, where when we were multiplying by tens, There was 1 0 in the product, just like there was 1 0 in the tens factor. When we multiplied by hundreds, there were 2 zeros in the product, just like there were 2 zeros in the hundreds factor. And when we multiplied by thousands, there were 3 zeros in the product, just like there were 3 zeros in the thousands factor. Does that pattern hold true for these examples? Pause the video to reflect on this and explain what you're thinking. That pattern of zeros does not hold true for these examples. There are a couple of ways we can reason through this. One way we can think about it is that, let's look closer at 5 times 2,000. With 5 times 2,000, 5 times 2 is the basic fact, which is 10. And then we have to think about the unit. 10 what? Well, it's 10 thousandths. Since the product of the basic fact already has a 0 in it, that adds an extra 0 to the product. Another way we can think about it is by thinking about decomposing the factors. 5 times 2,000 can be rewritten as 5 times 2 times 1,000. We can multiply 5 times 2, because remember, we can multiply in whatever order makes it easier for us. 5 times 2 is 10, and then 10 times 1,000 equals 10,000. Again, 4 zeros in the product because the basic fact product already has a 0 in it. Let's apply what we're learning now to solve a word problem. We'll use the RDW process to help us, and we'll start by reading the problem together. Ready? Read. Francisco played a video game and earned 60 points for every coin he collected. He collected 7 coins. How many points did he earn for the coins he collected? Now, pause the video and draw a tape diagram to represent the story. Then when you're done, come back and compare your drawing with mine. Here's my tape diagram. Does yours look similar? Because I knew that Francisco earned 60 points for every coin he collected, and he collected 7 coins, I drew 7 units of 60, and I labeled the total as the unknown. Now let the tape diagram speak to you. What does it tell you about how we can solve? In the tape diagram, I can see 7 equal groups, and I know the value of each group is 60. And we're looking for the total. That tells me that I can multiply 7 times 60, or 7 groups of 60, to get the total. So pause the video here and solve the problem using whatever strategy you'd like, and make sure to write an answer statement to answer the question. Then come back and we'll compare our solution pathways. Welcome back. Did you find that Francisco earned 420 points for the coins he collected? On the screen, you can see 2 different ways that you may have thought about the problem. Does one of them match how you thought about it? In solution pathway A, we decomposed the factor of 60 into 6 times 10. And then we multiplied 7 times 6, which is 42, and 42 times 10 equals 420. In solution pathway B, 60 was renamed as 6 tens, so solved in unit form. 7 times 6 tens equals 42 tens. And 42 tens, written in standard form, is 420. Great job today, friends. I think we're ready for the problem set. On the screen are the must-do problems for the problem set. Set a timer or watch the clock for 10 minutes to work on these problems. Of course, if you have extra time, feel free to try any of the other problems on the problem set as well. Today, we multiplied multiples of 10, 100, and 1,000 by single-digit numbers, and we found some patterns. Remember to check in with your teacher, and I'll see you next time for another Eureka Math lesson.